Space news. I'm just gonna take 5 and go stand up. I've been sitting down for 9 hours straight. Okay. Here we go. Yep. Back-to-back rocket launches. That's right. I'm going to put us on the title card real quick. I'm going to go stand up, walk around, and I'll be back in a moment.
Some may wonder why, but it's gone, everything you've done, but it's gone, everything you've done, but it's gone, love is but a pawn, yeah, but it's gone, everything you've done, you can't help but grin, how you lose this place to us, I won't let me win, you say you want your cut, yeah. Let it all crack and make it cry. You're confused. I love you. Some may wonder why, but it's gone, everything you've done, but I mean, serve your queen. Some may wonder
Okay, I'm back. Who's ready for space news? Okay. All right, let's roll. Nah, workers. No. Quickly, chat real quick. Impromptu launch in 50 minutes. Yeah. Impromptu? What? What are you talking about? We knew about this for a long time. Okay, so first order of business. Do you guys know what this is? Anybody know what this is? You going for a run, bro? Helium leak? No, I ran down to my house real quick. Is anybody specifically familiar with this project? You know what it is. Yeah. Stabilizer. Yes. Okay. Mike. It's not a DJI. It's a Feutech. All right. Here's my problem. Okay. This is one of the other things that I've been just doing in the background while workers like to kick me in the scrotum repeatedly. All right. So this is a Feutech 2S. All right. 2S. All right. It's a detachable gimbal, which is super cool. You can detach it. And, oh, I don't know. You can, for instance, put this on the side of a car because this is magnetic. Okay. See? Magnet. Right? We could mount it underneath the truck. You could mount it on the side of the truck. You could mount it on top. You could mount it looking back, etc., etc. Now,
Discovery, go and throttle up.
hey, for hire, 3-month resub. Now, the reason why I ask, okay, the reason why I ask what's going on is because I need help. All right, we bought one of these things. It's awesome. It's really cool. I got one from DOS too. We have a bunch of them, or we have two. Well, we have two of them, right? The one I got from DOS worked just fine. And he'd used it before, so it turned right on. All I had to do was hold the power button. Turns right on. DOS's does. This one doesn't. I bought this brand new in the box. It does not turn on. You charged it. Did you charge it? So here's the thing. It's USB-C, right? USB-C. If I plug this in and I plug the camera in, all that happens is a green and red light starts flashing on the side of the camera, and that's it. That's all. So when you plug this in, we've tried it into the wall, tried everything, tried all the stupid stuff, Wizard. We've tried all the stupid stuff. No. Take all the questions about, well, maybe you're not drawing enough juice, throw that out the window. We had this plugged into the wall. All that happens when you plug it in, there's a light on the side. It's right there above the USB-C port. All it does is flash red and green. Now, Freeman and I were like, okay, maybe it's DOA. It happens, okay? But so we returned. Well, we didn't return it. We RMA'd it, and Amazon sent us a second one actually quickly. So we have the second one. Plug the second one into the wall, and it did the exact same thing. Green, red flashing lights. I don't know if it's me, if I'm doing something incorrectly, probably that. But we cannot get 2 of the 3 of these now that we have to work correctly. There's no way 2 of them came defective in a row. This is it. Oh, yeah. Yeah, welcome to my life. This is a Feiyutech, Feiyu Tech, Feiyutech 2S. I've tried looking for color error codes. I've tried looking for all kinds of stuff. I cannot find anything. Press and hold the power down 10 seconds for a reset. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nothing. Is there a reset button on there? No. No. Can you try that plugged in? That doesn't do anything. The name of this thing is in chat. Now, see, here's the thing. The reason why I even bothered asking you guys is because, look, one, I can understand it. It's not, these weren't expensive, right? They're not that crazy for what it is, right? But 2 of them doing that exact same thing, that's not a coincidence. Element, I need to get this done. I need to get these cameras figured out, or else we're going to have 1 camera when we're set up for multiple cameras, dude. How long did you charge them for? I don't know. Bree, how long did you leave it on the charger? Sorry, EJ, but the indicator is in red and green. Maybe poor contact happened or cable inside was worn due to improper operations and transport. Please unplug the USB cable and plug it back in. Yeah, you got that right off the Feiyutech the Feiyutech website. Yeah, I know. Yeah, 2 times in a row? Unlikely. Last week I got a PC motherboard from Amazon, sealed, wrapped in QA inspection sticker done by Amazon. Inside I found brown paper and rocks in a Ziploc bag. Nice. So it would suck if we got made 2 of these things, or if we got sent 2 of these things broken completely, but what are you going to do? No, there's no, it's an integrated battery. Have you tried a different cable besides the supplied ones? Yep. Should be solid red while charging. Dude, it's not. It's blinking green red. It's blinking. The light on the side is flashing. I don't want to mess up my camera showing you guys, but here, actually, I'll just lift my keyboard up. Look. See it? See what I'm talking about? Both of them do that. No matter what we plug them into. Could be straight off the wall. It could be in a keyboard. Could be whatever. 5-volt 2-amp chargers recommended. Yeah, I understand that. That's what I mean, Deads. It doesn't matter. It's just, it does that. It does that every time. Open it and check the battery connection. Yeah. I thought you said 1 of 3 works. Yeah. Das sent us one. Right? He sent us one. His works. The one he sent us works just fine. The 2 that we bought brand new do not work. And there's no documentation on these damn things. Last, please. Red and green flashing could indicate a protection status issue, such as the gimbal's handle rotating rapidly or the temperature of the motors being too high. In this case, you should check if the smartphone is properly balanced and try to reset the gimbal. How do you reset the gimbal? Jared, that's the only thing I can think of, dude. Because once again, if one of these does this, I'm like, okay. If two of them does it, then there's something's weird. Thinking these things are old and the batteries inside are no good. Have you checked the serial number from the two non-working units? How would we check that? There's no way to. Instruction of initialization. Huh? That's a Vimble. That's a Vimble 2S, not a Pocket 2S, dude. Yeah, that's no good. That's not going to get me anything. Trust me, dudes. I spent all weekend trying to figure this out. And I just assume it was DOA. That's the only thing I could think of. What's this one? That's not the same thing, dude. This is a Vlog Pocket. It's not a Pocket 2S. You got one, Mutter? I'm just asking you guys to see if there's anything that I overlooked. Okay. All right, let's try this. What is this predominant? Yeah, okay. My other point was that model had an initialization step. Okay. Start to use. Please fully charge the battery before powering the product on for the first time. Okay. It's looking for a micro SD card. Yeah, has the integrated gimbal. Dude, we tried this. We tried putting in a micro SD card in there. This sucks because, yeah, we're going to be out. Formatted SD card. We were using the one that was in DOS's, so yeah, it was formatted because his works. Yeah, we took the SD out of DOS's card and out of DOS's Pocket 2S. Yeah, see what I mean, dude? This is a weird one. Yeah, didn't work. Yeah, plug this in, it doesn't do anything. It just sits there and blinks. Like, look, here, that's what it does. All right, well, you guys didn't, yeah, I'm not, I was just asking for you guys, like, to see if you could double check me, and you, yeah, all right. It's nothing immediately obvious, just in case I missed something like I would in Workers or something, you know? The battery might be under voltage. I'll leave this one plugged into the wall tonight, and we'll see. We'll see what happens. Could go into a surge protector. Probably should do that. Oh, okay, all systems. The indicator is just a charge indicator. I think the person who said the battery was DOA was right. Yeah. Yeah, no, it's... Looked up any YouTube reviews of it. Yeah, nothing of any substance. It's just, oh, look at how good this camera is. Totally wasn't paid. Hang on. I'll plug it into a surge protector. This is a 2.5 amp, so that should be more than enough. I'll leave it there overnight. We'll see what happens. Yeah, so I just wanted to see if there was anything immediate, guys. It's nothing immediate. Anyway, time for space news. Yeah, Brimo did the customer support thing, so we'll see. We'll see what happens. Looking at the menu for the Pocket 2S, there's no green grid flashing indicator when charging. Only, yeah, I know. I realize it's like it right in front of me, dude. Yeah, for sure, Breen. Keep an eye on the heat coming off of it. You don't want the battery to light up. Yeah. All right. We have a Starlink in about 30 minutes. Let's run through the quick stuff here. NASA announces that it's moving Hubble to a single gyro science mode. Not ideal. Okay. So Hubble has 3 redundant gyros on it, and they're moving it to single gyro because one of them saturated. The gyros are used to position the telescope, Dax. So, like, think about it. When Hubble is orbiting around, it needs to be pointed in the same direction. So you need gyroscopes to keep it pointed in one direction as it orbits, right? So, you know, as it's orbiting around, it needs to face the same direction, right? It has 3 redundant gyros. One of them failed completely. So NASA says that they're going to put Hubble into single gyro mode, which means it's just going to take longer to take the pictures because it can't turn as fast, right? But like a gimbal, too soon. Ugh. Rip. So yeah, that's what they're doing. Now, I can't help but think, dudes, like, here, let me just read the rest of this. NASA's Mark Clampin says that the change to single gyro ops won't affect the operations paradigm change review NASA announced in March to look at lowering operations costs of Hubble and That review is complete and being reviewed with an update this summer. How old is the Hubble Space Telescope? 3 decades. Now, some curious things. Hubble, part of the reason why it's lasted so long is because it was maintained by the Space Shuttle. The Space Shuttle did a couple of Hubble servicing missions. 109, STS 109 and STS 125, I think. So the last time it was serviced was in 2009, right? And what they did during that mission, what they did was they installed a grapple point on the bottom of this thing so something other than the shuttle could rendezvous and dock to it. Like a capsule. To do future servicing missions. Yeah, excessive. I know. So there is a thing that you could do with Hubble. Hubble's only in low Earth orbit. It's not that far away. Comparatively to like James Webb. If something breaks on James Webb, we're screwed. Or, I mean, Chandra you could get at as well, but, well, no, not really. But Hubble you can get at. That's what I'm trying to get at. So now, here's the real kicker. Hubble has the provisions on it to have another servicing mission go to it. But this is Jeff Faust. There was a press conference about this afternoon. I didn't watch a press conference because I was going to get annoyed. I knew I was going to get annoyed. You know, an operations paradigm change review NASA announced in March to look at lowering operations costs of Hubble and Chandra. Okay, see right there, that already pissed me off a little bit, implying that these relatively low budget science projects are, need to lower operations costs. That's good. Okay, now this next one. Clampin, after reviewing commercial options for rebooting Hubble, like NASA SpaceX studies, we have elected not to pursue any at this time. Concerns about risk of premature loss of science could revisit it in the future. Yeah, that is the exact reason right there why I didn't watch this press conference, because I figured that's what they'd say. So they're going to wait until it doesn't work at all to maybe think about rebooting it. They said they're not pursuing any options at this time. Thanks, Mutter, for the troubleshooting help. Yeah, I don't know what to say. I don't really have any words, and it's probably because of 9 hours of workers and resources, but I'm kind of speechless. All right. I just don't know. I don't get it. I don't get it. They're not going to pursue any options for doing a Hubble servicing mission because they're concerned about losing the satellite during a servicing mission, and there could be premature losses of science. This guy said this in the same breath as this. I, I, and then proceeded to answer media questions with all good things must come to an end. Okay, just stew on that one, Chad. I'm not saying nothing. I'm not saying nothing. You know exactly what I'm gonna say. I'm not saying nothing. I'm not saying nothing. Like his job should come to an end. Unbelievable. Now don't overanalyze his words. Yep. All right. Hubble has no option to boost or deboost. It's in a stable orbit and it relies on gyroscopes for attitude orientation. Just deorbit Hubble with the space shuttle. Yep, can't do that. Can't do that anymore. That ship sailed over 10 years ago. Yeah. Service Hubble with SLS. It's perfect. What, Orion? The capsule that they decided to test fly once and then say, yeah, we'll put people on the next flight. So, I don't understand why NASA, like Rocket Guy, maybe you can help me. Maybe you can help me. I get it, loss of premature science, right? And I get it that Hubble isn't exactly James Webb. James Webb is basically better in every single way. But I get it. James Webb is an infrared satellite. The Hubble's an optical one. I understand that. I get it. With all that being said, you had a tertiary, so tri-redundant gyroscope fail. What's to say the other two won't? What if the other one fails tomorrow? Then what? Right? Like, this guy's worried about concerns about the risks of premature loss of science. Like, and then in the same things, he's talking about operations costs. Wouldn't putting it in single gyro mode require more operational costs? I don't get it. Like, this doesn't make any sense. Can Hubble be serviced if it's adrift? Docking to something that's adrift is nigh impossible. If you've ever seen Interstellar, you know why. Believe it or not, that part is pretty accurate. And that was just drifting on one rotational axis. It's always a risk versus reward. It seems like the risks of a servicing mission at this time do not outweigh the risks of losing the gyroscope losses, since they technically still have two. It would be interesting to see the actual trade study results. I don't get it, man. I mean, the guy did say we're not going to pursue anything at this time, meaning that if another gyro fails, maybe they will. But it doesn't really hurt to do any trade studies. But then again, maybe they already have, and maybe they're waiting in the wings for it. You know, I have to give these folks the benefit of the doubt. You know what I mean? But still, it doesn't mean it's not a little frustrating. And that's the particular reason why I didn't listen to that press conference today, because I was going to get a little pissed off. I will say this, though, just on a side note, NASA's, people are trying to put, like, science stuff on the chopping block, and it's, not cool. What current crewed craft could take up a new gyro? It might be saturated. It might need to be rebooted. Who knows? I don't know. They said the gyro failed. I don't know if that means saturation or not, but whatever. It is what it is. Sounds like the others. Actual failure, increased friction. Yep. Can a gyro fit in Dragon's trunk? Even if it could, Katra, how are you going to get the gyro to the satellite? It's almost like these satellites were designed to be serviced in a certain way from a certain vehicle. I guess, well, whatever. I guess we'll just let it burn up then. All right. Is there even a successor to Hubble for visible light spectrum observation? If so, that could be a reason why they're not willing to save it. Not that I know of, Rem. What a wild robotic mission that would be if we could have a dragon trunk with a robotic arm. That'd be pretty cool. But yeah, I mean, that's the flip side of it, dude. What's the, how do you do this? How do you service this thing? If a gyro's gone, there are maintenance doors there, but they're designed to be accessed from a space shuttle payload bay. You know, like, what are you going to do? So we're losing capability again and again. Also, the current operating contingency plan is 20 years old, they say. So I guess that they feel like the plan with single gyro control is enough damage control for the moment. Set in the X-37B. Misadventures, I like you. Now you're thinking with portals. That's a good idea. Let's make another shuttle. I agree. Let's do that. And I knew one of the astronauts who serviced the Hubble a few years ago, Drew Faustel. Yeah, Joe. Yeah, that guy's cool, man. He's a race car driver too. If math serves me left, if I'm remembering right. Yeah, that guy wheels, man. That guy wheels and also flies into space. That's pretty cool. Yeah, pretty cool, man. Yeah, Jared, right. Yeah, exactly. Hopefully the gyro's not made by Fade Tech. Anyway, well, that sucks. Well, here we go. Flip to some good news. Check this out. Sure, John. Yeah, there you go. I wonder if a mission extension vehicle could do this more effectively than a manned mission. Maybe. He is. Show me a photo of him driving a McLaren. Hell yeah. Yeah, that guy's a huge car guy. That's awesome. I mean, I am too, Joe, but I haven't launched into space, so I'm probably not as cool as him. You know what I mean? But here's some good news. SpaceX got the FAA launch license. We're ready to go. Targeting a window, 120-minute launch window at 7 a.m. Central Time. That's 8 a.m. Eastern Time. For the people that watch this stream on the regular, that's 4 hours before my normal start time. I am going to be here for that, and I will do some cover. I'm going to be doing some coverage for NASA Spaceflight before that as well. Here, SpaceX put this promo video out. June 6th, Thursday. Yeah, I'm not going to be sleeping much in the next couple of days. We got Starliner tomorrow. A mini Canadarm would be needed T-Rex style. Yep. Starliner tomorrow, and then this is right after that. I need to start cooking up my out-of-work excuse. Say your connuter valve is broken on your truck and you need to fix it. Yep, there it is. We're going to see that thing fly, hopefully, on the 6th. No sleep for you. Yep. 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 So, yeah, we might not be playing much more games this week. It's going to be all space news and rocket launches from here on out, dudes. You know what? I'm okay with this. I don't know about you guys. I'm good with it. That's cool. So, yeah, SpaceX got the launch license. Pretty good. Pretty happy about that. 1016. Yep. That's pretty awesome. No sleep till burn it. Bow, bow. Yeah. So, actually, speaking of rocket launches, it's time. We got a Falcon 9, just in case anybody cared. This is Starlink Group 85. It's scheduled to go off in about 5 minutes. It's launching booster 1067 on its 20th flight after a 33-day turnaround. This is going out of Slick 40, Cape Canaveral Space Force Station. Interestingly enough, only 20 Starlink V2 minis on this one. Yeah, Shady, that's right. It's crazy, Rocket Guy. Yeah, this booster's 1067 is primed for a 20th flight. What else? You guys want to watch this or Gladiators? Gladiators. All right. This is SpaceX 58th mission this year. This has got direct to cells on this one, Kev. There you go. Currently watching this stream via Starlink. The meta is real. SpaceX has launched 58 times this year. That's unbelievable. They're on par for 100 plus launches this year, are on track for it. Last year, what did they do? 96? Okay, strongbacks moving backwards into the slightly retracted position. This is a throwback strongback, so it's going to just move back just slightly, and then when the vehicle goes, it's going to fly sideways. It's going to go that way. 96 last year. What is engine chill? Engine chill is thermally conditioning the engines. Because they're using semi-cryogenic propellants, i.e. liquid oxygen and kerosene, right? RP1. RP1 is just kerosene. RP1 is not cold. It's just kerosene. But the oxidizer that they're using for it, Laser Drifter, 36 months, thank you. The oxidizer that they're using for it is liquid oxygen. It's really, really freaking cold. Oxygen doesn't like to exist as a liquid down here. So in order to get it to be a liquid, you have to freeze the dang thing. And that's what all that condensation is. Note that condensation's only coming off certain parts of the vehicle. It's not coming off down here, where the RP1 tank is. The engine chill is when they open up small valves that trickle the liquid oxygen and the RP1 into the engine to prime it, but also to bring it down to the right operating temperature. Think about like an automobile. An automobile, you know, you have the C and the H on the gauge, and you want it to get right to the center, right? You have the C over here, you have the H over here, the gauge has got to go to the center. The operating temperature of the turbine machinery on Merlin engines is really, really cold. So they chill down the engines. During flight, you're going to hear them call Merlin vacuum chill, which is when they start thermally conditioning the second stage. It should happen about a minute before staging, give or take. Where's this launching from? This is Cape Canaveral Space Force Station.
LOX load is complete.
Stage 1 LOX load complete. Cape Canaveral Space Force Station. This is Space Launch Complex 40 or Slick 40 at Cape Canaveral. Note that Slick 40 also has a fixed service structure and a crew access arm. Pretty cool. Pretty cool. All right, so we are about 2 minutes and 20 seconds out from ignition. The tower does look rad. It's the lights, dude. The lights make it look ace. 39A is cool, but 40 looks clean, dude. No, it does look good though. It does look good, Rev. You ain't kidding. 58 missions, but only like 12 if you don't count Starlink. I mean, Rocket Guy, 12 is still pretty damn respectable. 12 is a high frequency if you're not counting internal missions.
LOX load is
That's a
complete.
lot for 6 months. Just saying. Not gonna lie, I kind of want SpaceX to launch from the Space Force Station before Boeing. That's probably not happening. When did 40 get a crew access arm? It went up quick, rocket science. They started earlier this year.
Ground gas closeouts has started.
Ground gas closeout has started, indicating second stage liquid oxygen tank is full. What you're going to see is a giant vape cloud being ripped by Falcon 9 right there. We get it, Falcon, you vape. No, what it's doing is it's getting that liquid oxygen that I was telling you guys about. It's getting it out of the fuel lines that are on the pad. You're running the risk of oxidizing your launch equipment and lighting that on fire by not evacuating the propellant. So what SpaceX did there was they opened up the external vent and they started pumping nitrogen up the line to vent all that the gaseous oxygen out. Falcon 9 has now gone into startup. We're T-minus...
Director, go for launch.
Launch director reports go. T-minus 45 seconds. T-minus 30.
T-minus 30 seconds.
That's what I was going to say. Guy interrupted me. 25. Good. Our first launch of the day. That's right, Brandy. 15.
T-minus 15 seconds.
I just said that. 10.
T-minus 10, 9, 8,
Sound suppression water system
7,
is on.
6, 5, 4, 3,
Engine
2,
ignition.
1. Ignition. And liftoff. Go Falcon, go Starlink.
Okay, we got a liftoff. Starlink Group 85 launching from Slick 40 on this Tuesday night. T plus 10 seconds, cleared the tower, cleared the pad. Vehicle now initiate.
Vehicle is pitching downrange.
It will pitch downrange, but it'll also do the roll
Stage
program.
1 chamber pressure is nominal.
Roll program. Yo, that's a northeast trajectory. It's northeast trajectory. If you're on the East Coast, you'll see it. This isn't a southeast trajectory. It turned too much. Oh, we can see this. Hold on.
Power and telemetry nominal.
Yep. Hold on. I gotta see if there's a clear sky. I want to see it outside. I'll be right back.
Mach 1. Maximum dynamic pressure.
Dudes, I got a clear sky. I'm going out in 8 minutes.
MVAC chill.
There's the M1D vacuum chill that I was telling you guys about. So that's second stage propellants are being trickled into the second stage engine, basically priming it and thermally conditioning it for ignition, which should happen right after main engine cutoff in about 30 seconds. From how far can you see it? Tin Town, I'm about
Nominal trajectory.
1,100 miles uprange from this thing. Bring a hand camera, preferably one with some kind of stabilizer. Shut up. Get it. Stand by for Miko. Ismic, maybe.
Miko.
Look southeast.
Stage separation confirmed.
Staging. Got a good ignition. Beautiful shot of the Floridian Peninsula
MVAC
right there.
ignition.
You can see all of Orlando and Tampa. That's pretty cool. Got a good ignition on the upper stage here. First stage now coasting here. Should be coming up on fairing separation.
Fairing separation confirmed.
Yeah, baby. Clean sep. Okay, you can see Florida off the coast up there. That's that big dark spot is the Cape. How many sats? We got 20 sats on board. Forgot to run ads. Sorry, I got into it there for a second, Cyberwolf. I saw it turned. So it usually turns about 20 degrees off the pad. This one turned like 90 degrees off the pad. Okay. T plus 4 minutes. First stage is coasting. It's not going due east. No, it's northeast. That's a northeast trajectory. I'm pretty damn sure. Go outside? All right. All right. I'll go outside. I'll be right back. Supersonic retro propulsion.
Discovery, go at throttle up.
Stage 1, entry burn startup.
Stage 1 FTS is saved.
Entry burn shut down.
Nominal trajectory.
Stage 1 is transonic.
Stage,
Stage 1 landing burn.
stage 2 is in terminal guidance.
Stage 1 landing leg deploy.
Stage 2 FTS is saved.
Stage 1 landing confirmed.
MVAC shut down.
You like Krabby Patties, don't you, Squidward?
Nominal orbit insertion.
Yes, I saw it. I saw it come over the horizon. That was sick. Oh, it still makes me happy. Yes. That's my smug face. Yes. Awesome. I got a picture. Probably doesn't look too good. Look. There it is, baby. Right there. Yes. Awesome. Oh, that just made my day, dude. Pixels, look at the pixels. Yes. Yes. Awesome. How was the landing? Was it good? Oh, I'm so happy. I was jumping up and down in my backyard. No joke. Let's see the landing. Oh, man.
Stage,
Stage 1 landing burn.
stage 2 is in terminal guidance.
Good landing. You got up, as I was saying, but it had the same angle trajectory as an ISS target launch. Starlink satellites are in a very similar orbit to the ISS.
Stage 1 landing leg deploy.
Inclination and SMA. Oh, yeah.
Stage 2 FTS.
20 flights. 20 flights for a 1067, baby.
Stage 1
Oop,
landing confirmed.
they're burping a little bit. Those are definitely pixels. Yeah, nodders. Why does the foil covering the engines look like it has a pulse? It's the reaction control systems on the second stage, dude. They're pushing up against it, and the turbine machinery is vibrating like crazy. There's a turbo spinning at like 30,000 RPMs in there. Oh, dude, nice! I can't believe that. Dude, look at between the other pixel right there. See it? We got it. We freaking got it. Dude, I saw it come out. I saw it pop over the horizon. I was like, yeah! I hope I didn't wake anybody up. Oops. Oh, that's cool, man. Just saw on Matt Malone's stream that he follows you. Really? Oh. Yeah. That's cool. Oh, that's awesome. That's, dude, so good. So freaking good. That just made my day. Anyway, that's a successful launch for Starlink 8.5. 20 Starlink V2 minis launching out of Slick 40. Awesome. Dude, I saw it turn. I'm like, that's a northeast trajectory, baby. There you go, Perry. Go, hell yeah. I was watching it. I'm like, that's turning to. Yes, we're gonna see it. You know, go outside. What direction is Electron headed? That's launching due south out of the Mahia Peninsula in New Zealand. I don't think we're gonna see that one, Bill. You ran? Yeah. That's awesome, dude. That just made my day. It's great when you see rockets fly. And dudes, I'm not gonna lie to you, I'm way up the coast. Like, if we go back here and look at this footage, right? They show the map view. I am way up the East Coast, and I saw it. Hold up. Let's get up here. So, I'm out. See that little hook right there? That little guy? Where it kind of bows out right there? My mouse cursor is basically where I am. I saw that thing, and just by sheer chance, you know, my house is kind of like on a steep hill, so my neighbor's house is down here, and then he cut a bunch of trees out in his backyard, so I have a perfect view. Like, if I look exactly due south, I can see it clear, but, well, not clear as day, but you get the idea. So I saw it, dude. I could, anytime there's a northeast trajectory, we can see them, which is super cool. That just made me so happy. Oh, sorry. I haven't seen a rocket launch since January, okay? NG-20 was the last rocket launch I actually saw other than on the internet. That's freaking cool, man. No, back it up. There we go. Yep. 54 degrees inclined here. So, yeah, we got 15 minutes till the next rocket launch, guys. We got another one teed up. Electron. What are you talking about? You see one almost every stream. Shh. Semantics question. It looks like the booster was going 65 to 7,000 kilometers an hour when it did supersonic retropropulsion. Hypersonic is defined at 5 times the speed of sound, which is 12,036 kilometers an hour. Wouldn't it be more apt to call it hypersonic retropropulsion? Yeah, but that's not what it's called. Electron is headed to a sun-synchronous orbit. Free Fire and Ice is a sun-synchronous. It's an SSO orbit, so 97 degrees inclined at like 500 kilometers is usually where those things end up. Or usually where Pre-Fire and Ice is probably going to end up. That's usually where sun-synchronous orbits go. Oh, nice, Chano. That's awesome. SpySat? No. Electron is launching Pre-Fire and Ice. Pre-Fire and Ice is a twin-sat combo. They already launched the first one. This is a 2-satellite network that's actually going... What they do is they monitor radiant heat coming off the poles of Earth. So it's a climate monitoring satellite to see how much heat the Earth actually escapes over the poles, right? That's what they're trying to do with these missions. So Pre-Fire and Ice is scheduled to go at 11:15. That's in about 45 minutes, but the coverage picks up in about 12. Dude, oh man, we saw it go. Oh, that's cool, man. Did anybody else see it? Perry, I know you saw it. Anyone else? Well, that was cool. Have a good night. All right, Batslot. See you, buddy. Oh, man, that's cool. Is this one heading over Spain? No. Ismic, you didn't get it. Jared, you got it. Excessive, you got it. I'm too far, near Quebec City. It was low on the horizon for me, Tintoon. It would have to be a super clear night for you to see it from up there. But you could. Rockets, you had clouds. Had a big block of clouds in the southeast. Clouds? Oh, man, dude. I can't. I'm sorry. I am going to keep incessantly showing you these stupid pixels. That's so good. Let's go. I'm sorry. It just blows my mind. That thing made it up to me in 8 minutes. 8 minutes. I am like 1,000 miles away from Florida. That's 1,600 kilometers. It made it up to me in 8 minutes. It's pretty cool. I had it from about T+5 until shutdown. Nice, man. Send them to Discord. Honestly, Bree, this is about as good as it's getting. This picture isn't much better because I zoomed in, because, yeah. 2022, I did manage to take a video of a Falcon booster turning around from Finland. Cool, water drop. That's awesome. Can you believe that? That's cool, man. I saw the thing turning and I'm like, okay. That's northeast. SpaceX usually launches on the northeast corridor in the summertime. The reason why in the summertime along the eastern seaboard, the waters are a little bit calmer than they are because hurricane season down south. So in the wintertime, they launch southeast over the Bahamas. In the summertime, they launch northeast. But I've noticed they haven't been launching northeast as much. So that's why I kind of freaked out, because it's very rare that you see it. Half of that fairing flew less than 2 weeks ago. Wow. That's cool. I have to say, it was kind of freaky to see it on the sky and no clue that it was a Falcon until the news on this morning. There, yeah, right. Water drop. There you go. It looks strange, right? You've never seen anything like that. It's just like, wait, that's not an airplane. Still wet with seawater. 2 weeks ago on that fairing turnaround. You gotta be kidding me, man. You gotta be kidding me. Okay, how did I know? Yeah, sure. So when a rocket takes off, leaves the pad, it does what's called roll program. Roll program establishes what's called insertion azimuth. Okay, so watch. Twitter video. Watch. All right, watch. So the thing's going to take off, right? This is a replay, guys. She takes off, right? And then SpaceX shows a camera that's mounted right there. It's facing downwards. So I could see the ground relative to the vehicle lifting off. All right, now watch. Now this camera right here, this is the one. It's important to note that this is actually on the side, okay? So let me give you some good orientation. Okay, so now this is a Starship model. Okay, this is Starship. This is not Falcon 9. Falcon 9 is what you see on the screen. I'm just using this so you can kind of figure it out, right? So obviously, with Starship, the wings are on the sides, right? So you have port, starboard, bow, aft. This camera right here is mounted on the side, looking down. Right? So the nose of the vehicle is obviously that way. It's behind us, but the bottom of the vehicle is this way. The belly is that way. So right now you're looking at Falcon 9 oriented like this. It's sideways. Right? Now watch. When it turns, right? Watch how much it turns.
Vehicle is pitching downrange.
Now, another thing you can extrapolate, and this is for no bigger reason than because I'm a huge freaking nerd. I know that this pad, Slick 40, all right, the flame trench faces east. I know because I've been there. I've seen it. It faces east. See that road right there? I've driven on that road. Yeah, don't ask. In my travels, I've driven on that road. Flame trench faces east. Now watch where the vehicle turns. So it's initiating the roll program, right? You can still see the lights on the lightning towers. There's the flame trench. If they were flying on a southeast trajectory, right? If they were flying on a southeast trajectory, the vehicle would have stopped right there. It would have stopped rolling, right?
Stage 1 chamber pressure is
But it's going to keep rolling. See? Now, the flame, see the plume from the flame trench right there? We still know that's facing east, so that's your reference. Starlink satellites only launch two ways out of the Cape. They only launch northeast or southeast. So I talked about insertion azimuth a little bit earlier. Insertion azimuth is basically what direction is the rocket going relative to the compass. Like the compass, you know, 90 degrees is east, 180 is south, 270 is west, 360 is north, right? So right now, the rocket, if it stopped rolling here, the insertion azimuth would be 90 degrees. 90 degrees does not get you into Starlink's orbit. Okay, here. Skyrogue. This is stuffin.space. If we go in here and we look at Starlink, there's a nice picture. Look, so check these things out. All right. So you see the shells. They're all tilted. Okay. Let me find Florida. See, they're all tilted. Do you see anything going this way? Right? Because if Falcon 9 had a 90-degree insertion azimuth, it'd be going for what's called a 27-degree inclined orbit, basically launching that way. The orbit would go this way. You should see an orbit like that if Starlink was going to do that. It doesn't. Like I said, it only launches northeast with an azimuth of about 45 on a northeast trajectory and an insertion azimuth at 135 on a southeast trajectory. So it's in an orbit like that. It's either going to be like that one right there, or it's going to be like that one right there. It's not going to be anything in between. So once I saw it go past east for the insertion azimuth, so that's 90 degrees, 80, 70, 60, 50, 40, and then it stops. That's how I knew. I knew right away. Once it swung past the flame trench, like past 90 degrees on the compass heading, I knew it was coming this way. They usually don't roll that much. How do I know all this? I've watched way too many of these. That's how I know. Yes. Kurzmako, exactly. Yep. So keep in mind, if you launch due east out of Kennedy Space Center, you launch due east out of 39A. 39A is 27 degrees north latitude. So latitude and longitude. So the equator's down here somewhere. Okay. You go 27 degrees up on the latitude scale. You're basically right at KSC. You launch east at 27 degrees north. If you with a flight azimuth of 90, you're going to wind up in a 27 degree inclined orbit. Now, we were talking about Hubble a little bit earlier. It's HST. We were talking about Hubble a little bit earlier. Hubble is 28.4. It's pretty damn close. That's basically the orbit that it's in. If that thing had stopped when the flame trench was perpendicular to the camera, it would have wound up in one of those orbits. That's not where it ended up, right? It's in a Starlink orbit. Starlink's only launched this way or that way, right? So what's inclination? What does that mean? 28 degrees inclined at 90. What are we talking about here? So there's Earth's equator. Earth's equator is basically the geographic center, or like it's the center line on this planet, right? Halfway between north and south. Okay. Where that orbit crosses the equator, right? If you make an angle of where it crosses, right? So say there was a straight line right here. If you make that into an angle, what's the angle? That would be 28.47 degrees. That's your orbital inclination. It's the tilt of your orbit relative to the equatorial plane of the planet you're orbiting around. Make sense? Yeah, I'm just a huge nerd when it comes to this stuff, dude. That's the biggest reason. I've watched hundreds of these things. And I'm also a little bit of an orbital mechanic nutcase. But yeah, there you go. So here's the thing. Launching with an azimuth out of the Cape at 90 degrees, 27 degrees north latitude, puts you into a 27 degree inclined orbit. If you're at the equator and you launch with an azimuth of 90, what's your orbital inclination? We're talking 0 degrees latitude. 0 degrees latitude, compass heading in 90. What's your orbital inclination? Who was listening? You should get a Duramax, don't I? Be quiet. 0. Yep. 90 degrees on the compass at 0 degrees latitude, 90 degree insertion apogee, 0 degree inclination. Your inclination, if your flight azimuth is 90, then your inclination will be whatever your north or south latitude is. So, say we launched from Boca Chica right here. Boca Chica is 25 degrees. 25 degrees north latitude right there. You're launching due east out of Boca Chica. So 90 degrees out of Boca Chica. 25 degrees north. 25 degree orbital inclination. Pretty cool, huh? I'm sorry I got lost. That's all right. How many Starlink satellites are up there? 6,000, I think. Yeah, little bit of basic orbital mechanics there. Basic orbital mechanics. Yep. It gets more complicated. If you want to get into a 54 degree inclined orbit, launching out of the Cape, you have to take into account Earth's spin. So your flight azimuth is actually going to be like 45. So 45 degrees out of the Cape, because the Earth is spinning, you're actually going to end up on a relative curve and end up in a higher inclined orbit, because the Earth is spinning. Because the Earth spins. Yeah. You have to take into account that relative motion when they launch rockets. So that's why some rockets look like they kind of dogleg in different directions. Pretty cool, huh? So are there any sats in 0 degrees? Yeah, of course. There's plenty. They're just not in low Earth orbit. Well, they're in high Earth orbit. All right, so we're talking 23,500 miles that way. Those are usually 0 degrees inclined. These are geocentric. Geocentric is out there. That's Earth's orbital plane right there. It's 0.02 degrees inclined. Don't polar launches go south-southwest-ish? Yep. That is mostly because, like, if you're looking at a launch out of Vandenberg Mutter or a launch out of the Mahia Peninsula like we're going to see tonight, sun synchronous. Sun synchronous have a azimuth insertion of about 190 degrees. It's a 190 degree flight azimuth, so they get into about a 97 degree inclined orbit. 97 degree inclined orbit are orbits that look kind of like that. It's kind of tilted. Once you get past a 90 degree orbital inclination or a polar orbit, you're moving into a different type of orbital inclination where you're going against the Earth spinning. So an equatorial orbit, right? Something like, let me just find something. There's a lot of stuff. That Starlink is 54 degrees inclined. That's still 54 degrees off, but it's still going in the direction that the Earth is spinning. That's called a posigrade or a prograde orbit. Once you get past 90 degrees inclination, you get into NOAA-1, which is an atmospheric satellite. I just clicked on it by random chance. We're talking 101.46 degree inclination here. That's past the polar plane right there. So the difference between geographic north and geographic south. Once you get past that, you're going against the way the Earth is spinning. That's called a retrograde orbit. Retrograde orbits are satellites that orbit this way. They orbit clockwise instead of counterclockwise if you're looking at it from the top. Posigrade orbits go this way. Posigrade orbits exist from 0 degree inclined to 90 degrees inclined. 90 degrees to 180 is a retrograde orbit. Now I know what you're going to say. Why isn't there why isn't there like a 270 degree inclined orbit? Well, a 270 degree inclined orbit would just be a 90 degree. That would be just actually 270 degrees inclined would be the exact same as a 90 degree inclined orbit. It would be the same thing. Because they're both up. Basically, you can only go that way and you can only go that way. So it's only 180 degrees. You can only go east or you can only go west. So inclination is measured on 180 degrees. Pretty cool, huh? A little bit on satellites. It's good stuff. Real good stuff. It's my favorite. I love it. Not related, but Edison posted some renders. I like the new stuff. That's pretty hot, dude. That's pretty hot. Yeah, you can go double east, right? Yeah, CJ. Well, don't worry. We got more. Rocket Lab is live. Let's see. So Rocket Lab, these Pre-Fire and Ice are satellites that they're designed to... Pre-Fire and Ice are two sets of satellites. This is 2 of 2. The first one's already launched. Rocket Lab already launched it. These satellites are designed to go into a 97-degree inclined retrograde orbit. So, like that NOAA-1 satellite, a lot of climate monitoring satellites are in this type of orbit. A lot of spy satellites are in this orbit too. These types of orbits are what's called a sun-synchronous orbit, or an SSO for short. Okay, why is it called a sun-synchronous orbit? What is that about? Well, okay, here's the thing. This is going to be a little bit of a mind frick, okay? So sun-synchronous orbits are a type of orbit that flies over the same spot at the same time every day. Now, I know what you're saying. How are you going to do that? How does that even happen? Well, sun-synchronous orbits take advantage of something called precession. What is precession? What does that mean? I could get into angular momentum and, offset center of mass to center of gravity, etc., or center of gravity to the geometric center, etc., etc. Long story short, we all know Earth has an axial tilt, right? And it's spinning. So think about if you have a top and you spin a top, right? Eventually the top's going to start doing this. Earth does that. It weeble wobbles around. Now, why? Why does it weeble wobble around? Well, the center of gravity of Earth is not in the exact geometric center. Okay, Earth is not a perfect sphere. It's an oblate spheroid. It's like a big jello mold that's just kind of floating around in space. And we're floating on the cooled crust of this big, gigantic jello mold. There's always room for jello. Okay. So, because of the Earth weeble wobbles around, it imparts a perturbing force on these sun-synchronous satellites that actually gets them to shift their orbit a little bit. The satellite's orbit shifts with the day-night cycle. It's weird. It's weird stuff, dude. So, spy satellites, for instance. Say you were spying on your adversary's missile base, for instance. Does it matter to you if the satellite flies over at night? What the heck's that gonna do? That's gonna do nothing. You're not gonna see anything. It's dark. All they have to do is shut the lights off and you're never gonna see it. Right? They figured this out during the Cold War. So, they figured this out in the early 60s. They could just shut the lights off and we wouldn't be able to find them. So, engineers came up with the idea of using Earth's precession to move a satellite's orbit around in space without any thrusters on the satellite. It uses that weeble wobbliness to move the satellite around. And the satellite gets over where you're trying to image at the same time every day. Say at 8 in the morning when the sun's coming up, so everything is nice and illuminated. You get a nice golden hour. Yes, they care about that with imaging. Yeah, it's a photograph after all. Just saying. What orbit was GoldenEye in? Why not just put it in geo? It's hard to image something from 23,000 miles away, Katra. That's why. Sun-synchronous orbits are usually about 270 to 370 miles that way. It depends on what you're trying to image, what latitude, what longitude it's at. It really depends. So the orbits do vary. I love how the satellite has vertical stabilizers. Judging by these cameras, okay, you're gonna think I'm pulling this completely out of my tailpipe, and to be honest with you, I probably am. Judging by those cameras, orientation of the camera, I'm gonna go ahead and guess. I think it's safe to guess that the North Pole is up here and the South Pole is down here. So you're seeing the satellite over the Northern Hemisphere. If we're somewhere at this particular moment over a degree of 45 degrees north latitude, that actually makes perfect sense. The GoldenEye satellite would have most likely been launched by the Soviet Union out of two places. Plesetsk, the Plesetsk Cosmodrome, which is kind of where Severnaya is in the movie, or it would have been launched out of the Baikonur Cosmodrome. Now, the way the satellite's orbiting in that picture shows that it probably didn't launch out of Plesetsk. The Russians used Plesetsk to launch stuff into sun-synchronous orbit. That's where their spy satellites are, just like ours. They also use Plesetsk for orbital insertions for Molina orbits, for lightning orbits, for communication purposes and signals intelligence and a couple of other things that we don't know about, but probably would like to. So, none of those would have a satellite in low Earth orbit moving left to right on the screen in the Northern Hemisphere at over 45 degree north latitude point. The satellite's going this way in the movie, right? It's going that way. It's not going this way. If it launched out of Plesetsk, it would be going this way on the screen, but it's not. In this particular shot from the movie, it goes that way, right? So that indicates a posigrade orbit. So that means it launched out of Baikonur. What's Baikonur's north latitude? Baikonur is 45 degrees north inclined, or 45 degrees north latitude. The trajectory that the Russians take out of Baikonur is a little bit of a dogleg right trajectory. The reason why is they fly around Mongolia when they launch. Also, you don't want a missile heading towards China. Those two kind of had some bad experiences with that in the 1960s, but that's another story. So, if the rule of thumb here is that this thing, Rocket Lab starting. The rule of thumb here is that this thing launched out of Baikonur. So 45 degrees, it would have put it into a 45 degree inclination. Baikonur can access that type of orbit. Absolutely. So if it accessed that type of orbit and we know it launched out of Baikonur, in the movie, the guy says it's in low Earth orbit. How do we know it's in low Earth orbit? The general reports to Oromov when he's at Severnaya that it's in a 90-minute orbit. 90-minute orbit indicates about 500 kilometers circular, give or take. So 45 degrees inclined, 500 kilometers circular. You're welcome. Rocket Lab time. You thought that was a joke question.
Hello and welcome to the launch webcast for our 49th Electron mission, set to launch from Pad B
I am
at Rocket
invincible!
Lab Launch Complex 1 in New Zealand in just under 19 minutes from now.
Was it
Today
good for
we'll
you
be launching
too?
the second of two launches for NASA's Climate Science Pre-Fire mission after standing down a couple of days ago due to out-of-bounds LOX temperatures. Thanks for joining us. My name is Muriel Baker and I'll be taking you through today's countdown to liftoff for the pre-fire and ice
Tobacco, it
mission.
would have to be from
Currently
Baikonur
set
and it would
for
have to be
launch today
Proton,
at
that's right.
3:15 p.m. local time or 03:15
Slughead.
UTC. Now, Pre-Fire and ICE is the second of two back-to-back launches on Electron to deliver NASA's satellites to orbit for the Pre-Fire mission. Pre-Fire stands for Polar Radiant Energy in the Far Infrared Experiment, and it's a mission designed to measure heat loss from the Arctic and Antarctica to help improve climate and ice loss models that better predict Earth's ice, sea level, and weather changes. The first satellite in the pre-fire mission was deployed by Electron to its 525-kilometre orbit 11 days ago. After today's second launch and deployment, the 2 pre-fire satellites will spend the next 10 months crisscrossing Earth's coldest regions to collect their data. And once they're operating, pre-fire will make the first full spectral measurements of far infrared radiation, revealing the full spectrum of Arctic radiant energy. Now, those measurements will then be used in climate and ice models to help better predict Earth's sea ice loss, ice sheet melt, and sea level rise. Pre-fire is focused on the Arctic and Antarctica because these polar
Discovery, go
regions
and
have
throttle
a
up.
big influence on the Earth's temperature. Excess heat escapes from there to space,
Colin.
and the difference between how much heat is released versus how much heat is received from the sun in the tropics is a key influence on the planet's temperature. Better understanding this process and what it means for Earth's future climate is what the pre-fire mission is all about. Here's NASA to explain more.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable
I'm totally
knowledge
not
gap
pulling
in
up
our
golden
understanding
eye,
of
swear to
Arctic
God.
climate.
Pre-fire is going to fill this important gap.
Pre-fire, polar,
Radiant,
Energy
in the far.
infrared.
experiment.
So Earth's temperature
I'm totally
is
not
set
either.
by
Shut
a
up.
balance between the amount of energy the Earth receives from the sun
This is good too.
and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy. And we have no modern satellite observations of this incredibly important energy spectrum. Pre-fire will be deployed
Damn, I'm
to
good.
CubeSats. Over the course of a year, they're going to be measuring.
That's actually a
the
lot
far
higher than
infrared
45
energy
degrees
for the very
inclined,
first
but the
time
orbit was
that's
more or less
moving on
right.
top of our atmosphere.
Wait,
Each
which
of
way
our
is that thing
pre-fire
going?
CubeSats carry something called a thermal infrared
Check it.
spectrometer that looks down at the Earth and gathers energy being emitted from the planet. at different wavelengths.
All right, cool.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow. And what happens is light gets dispersed.
That's more than 45
Similarly,
degrees
you see
inclined.
the
That's actually
different
pretty high
wavelengths
inclined,
split
80
up,
degrees at
and you can
least,
measure
which
each of
means
these
it could
wavelengths,
launch
and
it.
that's
It
what
could have
the
launched out of
spectrometer does.
Plesetsk.
It
Anyway,
spectrally separates
back to this.
the radiation into different wavelengths.
Sorry.
These wavelengths
Seen
are gonna
GoldenEye
give
too
us
many
really
times.
important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
That's hot.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite
thank you,
comes
Butter.
along and measures the scene over the poles. And then a few hours later, we
Thanks,
have
Butter.
the second one come along in a different orbit and measure the
No,
same
it didn't.
scene. So
Yeah,
you understand
they just drew a
impact of
squiggly line on a
how
map,
the energy
Dinkelberg. It's going the
changes
wrong
in those
way.
few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get.
I mean, I'll be 100% honest with you. If I was going to launch some type of pulse weapon, nuclear pulse weapon like that, it would be in sun synchronous. Yeah, that's where I'd put that.
What we want to do with pre-fire is we want to take
Basically
new
where this thing's
observations
going.
that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be
Oh yeah,
affected by
Versity,
them.
there you go. Actually, Spoon, to be 100% real with you, that part, the part that M talks about in GoldenEye, about discovered by the Americans and Soviets during the Cold War. It creates a pulse radiation surge that destroys everything within the electronic circuit. Set off a nuclear device in the upper atmosphere. Yeah, that's actually real. That actually is a thing. GoldenEyes can exist. Yeah, they do. They absolutely do. Yeah, they absolutely exist. In theory, no one's ever done that because of the Partial Nuclear Test Ban Treaty. It is very, very much against international law. Oh, excuse me. It's very much against international law to do something like that. Because you don't. So, okay, we're going to nerd out here again for a second. Whenever you do that, you blow up a nuke in the upper atmosphere. Obviously, you're going to spray the ground with electromagnetic pulse, but you also, the nuke goes up, EMP goes up. And that all that radiation gets stuck inside of the Van Allen belts. And believe it or not, once again, they figured this out during the Cold War, which is nuts. Depending on where you blow it up, that radiation gets picked up by the Van Allen belts, and it'll get inserted wherever the Van Allen belt goes back into the atmosphere. So what you could do, theoretically, is you could launch a nuke out and blow it up out over the middle of the Pacific Ocean, and if the Van Allen belts were lined up right, that you could basically like send that electromagnetic pulse. Like, you don't even need to blow up a nuke over your target. You need to blow it up somewhere kind of wherever the magnetic field comes down correlative to it. It's directional. You can steer it. It's weird stuff, dude. But yeah, they did figure that out. It's wild stuff. So, like, you could blow something up over the South Atlantic anomaly, and it would fry a good deal of things that are on the other side of the planet, which is weird. Yeah, it's like fiber optics, but with radiation. It's wild stuff. Yeah. They figured that out a little while back. It's pretty damn cool.
15 p.m. local time,
All right, anyway, I'm gonna shut up.
03:15 UTC in approximately 10 minutes, 39 seconds. While all eyes are on Electron's launch today from the Southern Hemisphere back in the United States, we have a team working steadily on a mission of another kind
Interesting, nice.
for our new big rocket, Neutron.
Oh, yep.
We have the first...
Yep. Here we go. Running ads. Oh, Archimedes. Hold on.
being prepared for its first hot fire in the coming weeks.
What if
and
you
we'll
farted
have 9
there?
of these engines.
Someone's going to smell it on the other side of the planet, Pope. But then again, farts aren't radioactive. But wouldn't it be cool if it did that, though? I'm not going to say. Maybe we should test it. Just saying. That might be against the Geneva Convention, though. I don't know what, like chemical warfare or something, dude. But it depends. If you had like a salad or something, it might not be a big deal. But if you had Taco Bell and then did that, maybe your farts aren't radioactive. I mean, it depends, right? It depends on what you eat. Maybe I want some Kansas City barbecue with baked beans, and then I'm pretty sure the fart would be like against international chemical weapons laws, all right? Like that is a biohazard, dude. All right? What I wanted? I'm gonna be farting blood over here. Anyway, I'm running the ads. Now that we've completely nosedived the stream, I'm gonna run the ads. What if we all had ice cold farts? I don't know, man. Let's just watch these rockets.
Housing wiring going on. That's being worked real time with software. Back in our control room, the human machine interface HMI that we use to control things.
Red team
Those
go.
things are in the
Red
final
team
press
go.
and final checkouts. We're ready now to push the engine through final commissioning and ready for hot fire.
All right, fast forward.
Rocket Lab came into NASA.
Preparing to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. The hell am I looking at? When does this happen in the stream? Chat, now. You're looking at now. Everything you see now is happening now. What happened to then? Well, you missed it. Just now. You're at now. Soon.
How to make rocket operations work. So we got that community of people here to support us, and it's a great place to be for a commercial company to be in the middle of this with all that support and the ability to run our operation.
Well, you
My
passed
sincere
it.
appreciation for the team that we have here at Stennis, the team globally with Rocket Lab. We've had support from New Zealand and Long Beach and from Wallop. So they've come together here. We put a ton of work in here in the last year, and to see it all come together should be exciting for all of us. The team deserves a huge congratulations from everybody involved that have gotten us this far.
Thanks, Nikki. They're not even using the good part of the test stand. They just built this little baby thing right there. Use the big test stand. That's the A3, man. Test stand. When did I miss it? Now.
Open roles in manufacturing, design, engine development, and more across
nice,
several
Reb. There you
states.
go.
You should check out rocketlabusa.com for your options.
You're preparing. You're always preparing. Just go. Just go. I'm watching GoldenEye after this, man. I'm not going to lie to you. Yeah, I'm definitely watching GoldenEye after this. Look what the satellite picked up. We found a match. Your missing tiger in the middle of northern Russia. Looks like your hunch was right, 007. Too bad the evil queen of numbers wouldn't let you play it.
T-minus 6 minutes, 27 seconds to launch.
I'm not
Let's
crazy,
take
I
a look
swear.
at the Electron
I
rocket
swear.
for
No,
today's
where are you
mission.
going?
Electron is a 3-stage
you
liquid
think-
fueled launch
think they're gonna
vehicle
come back?
designed specifically for
No?
small satellite missions. And over its 48 missions to
They're gonna
date, Electron has deployed more than 180 satellites across various low Earth orbits for science, commercial, and national security missions, including a mission all the way to the moon for NASA.
Rocket Sage! 118-person raid. Oh, you guys are just in time. Look. Sage raid. Pigeon, how big is this? Look at the staircase and the railings. Electron is a tiny rocket, but Electron is cool because it uses electronic fuel injection. Most rockets use a turbine and an impeller. Basically, it's a jet engine attached to a fuel pump, right? Most rockets do that. This one doesn't. This one has an electric motor attached to a pump. There's 9 Archimedes engines in the first stage. They're electronically fuel injected. It's EFI. Yep. If you're a car guy, you're like, really? I'm like, yeah. And you heard that right. Also, if you're a car guy or gal, Rocket Sage, I don't know if you are. Thank you for the raid, though. Rockets use a turbocharger to pump fuel. So it'd basically be like having a Holley fuel pump attached to a turbocharger. Except there's no charger, there's no compressor, there's just a fuel pump there. So as you spool the thing, you deliver more fuel. Yeah. That could get a little hairy. It's almost like it's really easy for this stuff to blow up if you don't know what you're doing. Right? Am I right? Rocket Sage, anyway, thank you very much for the raid. It's great to see you. You're just in time for the Electron Pre-Fire and Ice, which is a satellite that's going to monitor polar radiant heat. It's the first of 2. This is a NASA payload here launching on Electron. This is the Mahia Peninsula in New Zealand. And it's launching due south. Flight azimuth 190, if I'm remembering right. 97 degrees inclined at 500 kilometers. There's a bug in front of me, and I got it. Awesome. Oh, no, get back here, you son of a... Anyway, moving on.
Full orbit first. So, to course correct to a circular orbit, we wait until the kick stage
Rocket Sage.
reaches the other
How are
side
you?
of the planet and the trajectory's apogee, which is its highest point, close to that 525 kilometer target. Now, once here, the Curie engine will
may
light
have
up
been
to
2
set
bugs.
a circular course around Earth, before a few moments later releasing the payload to space and ending the mission for Electron.
It's a fly in here. I'm
now,
sorry.
all of that
It's like
is
that episode of
coming up
Breaking
shortly,
Bad.
now that we are just 3
That's
minutes
correct,
and
Pigeon,
45 seconds until liftoff
I'm gonna move over there
of
and get out of the way.
Pre-Fire and Ice. It's time to send it over to Mission Control to take it from here for the remainder of the count, and I'll be back with you shortly after liftoff. Go NASA, go Pre-Fire, and go Electron.
How's chat tonight? We're doing great. How are you, Rocket Sage? What were you up to? Doing some STEM streaming, I trust. Yes. Just teaching geology like usual? Oh. That rocks.
And to all operators, LD and mission code. From now on, there should be no red
Sorry,
flags
Unagi.
on your critical LCCs.
You're a dork. Yeah.
Beacon LD mission
Yeah.
code.
LD beacon.
Okay, hold
Please
on.
lock the auto sequence and
Serious
confirm.
face.
Auto sequence is locked.
Hi, Natch.
Beacon, please confirm all expected primary flight computer ASCOs are green.
That's confirmed.
Jesus, it's green.
We go for an auto sequence start at T-minus 2 minutes. LDs go for
I've
launch.
been hanging around with Sawyer too much, man. I'm telling you. Launch director reports go T-minus 2 minutes and 30 seconds on pre-fire and ice. Little overcast down in New Zealand today, it seems like. Actually, it's the middle of the day there. It's tomorrow noontime. It's lunchtime. No, Chief, not that I know of. He's faced it well. Shh. Does Rocket Lab even need a flame trench? The flame trench is actually built into their launcher, Repairy. You'll see when it goes up. Sheep are
Vehicles fully
green.
on internal power.
Okay.
AFTSs are green and enabled for flight.
Flight termination system is on. Vehicles on internal power, meaning it's using its batteries to power all electronic systems on board. They've cut it from the grid. They didn't actually cut it. They just flipped the switch that powered it.
Lock load is complete.
I got raided by Middleditch too? Tommy Two Tones, how you doing? Hey, what's going on? Are you still capping people or something? I just rocket launch. Give me a second. Dude, we got Rocket Sage and Middleditch right at the same time, right in time for a rocket launch. Watch this thing go. This thing is great.
Anti-geysering is disabled.
Are you still no capping people or speaking Zoomer or whatever? I don't know how to do it. I'm not good at it. I don't know what to do with my hands.
Stage
seconds.
Stage 2 tanks are pressed for flight.
High flow engine purge and
Really, Marilyn? What was Middleditch up to tonight? Was he just doing the normal GTRP? I went back and watched that VOD. It was weird. Not gonna lie to you. It was 30 seconds. Chat is go. Middleditch is an awesome streamer. Give the guy a follow. Damn good RPer.
We are T-minus 20 seconds and counting.
Okay. The sound suppression water system should be turning on here momentarily. Look down there.
10, 9, 8, 7, 6, 5, 4, 3, 2,
Send it.
1. Lift off.
That view was good. Okay. Got another launch. 2 out of 2 on the day.
Beginning pitch over.
Vehicles pitching down range. 190 flight azimuth, chat. 97 degrees inclined. Got to take into account the spinny.
Stage 1 propulsion.
There goes our
wild
49th
RP.
Electron
Cool.
rocket soaring off the pad
Awesome.
at Launch Complex 1 and on its way to space for NASA. We are now 39 seconds into the mission and our first mission milestone is coming up called Max Q. This is when Electron reaches the maximum amount of pressure that will work against the rocket as it
Everything's
powers
looking
its
good
way
here.
through the atmosphere. We should hear a call out from Mission Control soon that Electron has made it through that structural test.
1 minute into the flight here. Electron is a much
High
lighter.
voltage battery discharge nominal.
Okay. Batteries are powering the fuel pumps just fine.
Cleared max Q.
That's Electron
Little bit of
smoothly
vertical
through
wind shear.
Max
See
Q
it
as
kinda
the
sketching
mission
around? That's
continues.
okay.
We are now at 1 minute and 18 seconds into the mission as Electron passes more than 18 kilometers in altitude at more than 2,300 kilometers an hour.
So if you see it sketching around, that's okay. Electron, because it's made out of carbon fiber and it's a smaller rocket, you're gonna run into some stability issues here. Not issues. They're not running into any issues. It just tends to move around a little bit more.
Followed by the engine startup on Electron's second stage to carry onto orbit with NASA's pre-fire satellite.
Yeah, a little
Standing
bit,
by
little
now to
overcast
listen
down in
out
New
for
Zealand.
Mission Control to check off those milestones.
Yeah, Jared, exactly. It happens on the smaller rockets. Smaller rockets can get pushed around by the wind a little bit.
US Chathams.
When rockets launch, you got to worry
Stage 1
about
propulsion is holding nominal.
You gotta-
Stand by for MECO in roughly 30 seconds.
you got to worry about vertical wind shear. The wind might not be blowing down here, but it might be blowing up there. And going from the wind not blowing to like high winds really fast is what causes that skitching. It kind of moving around a little bit. It's called vertical wind shear, and it's
15 seconds till staging.
it's a commit criteria for launches. You don't want to basically run into a brick wall of wind at high altitude. It's not an AI
Miko
voice.
confirmed.
They're from New Zealand, dude. Okay, a little bit of a coast here. Stage separation.
Confirmed.
Oh. Haha. Very nice.
That was
Good
Miko,
staging.
stage separation, and second stage engine
It is
start
windy
for
up there.
Electron. The second
Well,
stage
not
Rutherford engine
anymore.
is
Where it
glowing
was,
hot
it was-
and bright
there was a
as
little
it
bit of
carries
winds.
onto orbit. Now more than 100 kilometers above Earth and moving at more than 8,000 kilometers an hour. Now this engine is identical to the sea-level Rutherford engines used on Electron's first stage, with that exception of a larger expansion nozzle that allows for improved performance. Next up is fairing jettison of the rocket's nose cone. And the fairing is what protects the satellite on Electron
Watch
through
the left
flight.
side of the screen.
But once Electron is ready to be rid of the nose cone, each half of the fairing is
When the fairing
designed
goes,
to
you'll see
rotate
it.
on a hinge away from the
You'll
payload
see
in a
it
safe
move.
separation
You'll
motion.
see two of them.
And that action
here and here.
is due now in just a few moments. So let's listen in.
There's a yaw and a pitch rate on this thing, and it's correcting it, but it's smoothing it out. It was doing this a little bit. That's okay. Second stages basically have really smart avionics that's designed to take into account that the wind may have blown the rocket around on its initial ascent. So you saw this right at staging, right? You could see the engine actually kind of doing this. It's kind of just compensating a little bit, and it kind of dialed it in. See how it's not moving anymore? What it was doing is dialing in the trajectory. Ooh, fairing cam. Bye-bye.
Confirmed.
Watch the left and right side of the screen if they show the engine again. You'll see it over there.
And there they went. Electron's fairing halves have split and fallen away from the
Guess
rocket
not.
as planned. Now that nose cone is ejected
Guess
once
we
we
didn't
reach
see it.
space, and we
You
don't
shouldn't
need
usually- they
protection
usually show
anymore
it.
for the NASA pre-fire satellite that is on board. We're heading to a 525-kilometer orbit for this mission, but stage 2 will only take us to just over 200
Was it down there,
kilometers to
Joe?
our perigee,
Yeah, I may have missed it.
where we'll
Sorry.
separate the kick
I
stage that
missed it.
has the pre-fire satellite. So
I'm looking
another
over here. It's
100
down
or so
there.
kilometers
Nice.
to go for
Center
Electron's
bottom?
second
Cool.
stage.
As long as you guys saw it, that's all I care about. It's cool to see. I've seen it a bajillion times. It's fine. Don't do that again. There's one piece. Oh, all right. Sweet. Excellent. Sorry. I missed it. You hit it with your finger when you said look there?
We are
Sorry.
approaching the
I couldn't
next
see it.
mark
My
in
hand
the
was
launch
in
for
the way.
Electron's second stage, an action that you'll only come across with our rocket called the battery hotspot. The Rutherford rocket engine powering the second stage uses batteries as the power supply for its propellant pumps. Now, those have been running for some time now, so the battery's power levels are running low. And to prevent an engine stall, we swap out those dying batteries with a fresh pack that will keep the engine running its full duration. Now, those old battery packs are ejected once they're done, which you can sometimes see on your screen as they fall away. So watch out for those just after the T+6 minute mark into the mission.
Burial's not an AI, dang it. She's a person. They're just from New Zealand, mate.
Throttling down.
All right, watch the silver thing over there, all right? My hand won't get in the way this time, I swear. I'm just going to keep my hands right here.
Battery
Bye-bye.
jettison confirmed.
Because it uses electric motors to spin the turbine, they need batteries. And when when the battery's out of charge, get rid of it. It's dead weight, just like an empty fuel tank.
Its current trajectory towards that perigee and moving along at
That's
more
exactly
than
what I'm saying, Lurker.
15,000
What are you going to do
kilometers
about
an
it,
hour.
Stein?
We have a couple more minutes to go with Electron's second stage as we approach its final set of actions with engine
Is there an
shutdown
old
and stage
Zealand?
separation expected soon
Yeah?
after we tick over 9 minutes into the mission.
Chat, tell Kuro where Old Zealand is. Who knows? Who's a good geographical person? A geographikizer.
7
Earth?
minutes and
You
10
got me
seconds
there.
into the mission, well over 17,000 kilometers an hour now, and things are
Nice.
looking nominal for that second
It's New
stage
Jersey,
engine
isn't it?
burn.
No.
The next milestone for this mission will be the second engine cutoff on that second stage, which we're coming up to in just a few moments.
It was just called Zealand. Yeah, Holland.
Battery discharge holding nominal.
Hey, everyone. I am from Holland. Isn't that weird? Yeah, they're getting some combustion pops there. Ooh. Ooh. Nice. 176C. I love gold. Look at that nozzle. It's almost glowing gold. No, that's fine. Joe, this could be the ablation on the nozzle. This could be some ablation on the nozzle. This is most likely due to...
Stage 2 propulsion is holding nominal.
I guess the right way to say it would be not an exactly uniform explosion from using Carolox. You kind of see this with Falcon 9 a little bit too.
It's now 8
Those
minutes,
sparks,
16 seconds
that's
into the
normal.
mission,
That
which
happens all
means
the time.
we are coming up on the engine shutdown for Electron's second stage, to be followed shortly afterward by stage separation of the kick stage that is carrying NASA's pre-fire satellite.
What I am
The process is
kinda worried about
practically
is
the
that-
same
that
as the
little guy
first
seems a
stage
little
engine
hot.
shutdown and stage separation that Electron performed earlier in the launch. We'll know that it's been successful when we see that red hot
got me
engine
there,
nozzle on the
survey.
screen start to turn cold with that successful engine shutdown. We're waiting, though, on the call out from Mission Control for confirmation of those actions.
According to Peter Beck, it's carbon buildup on the injector.
Guidance is in terminal.
I'd believe
20
that.
seconds
It's-
remaining.
This is just Carolox, man. Yeah. I mean, Mab, they're probably running a little bit on the fuel-rich side, running a rocket engine at stoichiometric, which is the amount of oxygen relative to fuel being delivered to the engine for the people that don't know. If you run stoich, it'll melt. So what they do is they run a lot of extra fuel into the engine, and that fuel, so a lot of that fuel combines with oxidizer and blows up. But some of that fuel is just there to take the heat from that explosion. It absorbs the heat and they shoot it out the back. That's most likely what you're seeing there.
Stage 3 separation confirmed.
Good kick stage separation. Nominal transfer orbit, baby. 28,554, indicating a higher than Leo there, 223.6.
Successful engine shutdown and a clean
good.
stage separation for Electron.
It's
The kick
septic.
stage has been
Septic.
released at its perigee
Yep.
with its attached
Nice.
pre-fire
Nice.
satellite ready to join the first
Nice.
pre-fire
Nice.
satellite deployed
Nice.
to space
Nice.
just last
Nice.
week.
Nice.
Now, with the kick stage released onto an elliptical orbit first,
Land center or mission control room, chat? I'll let you be the judge.
orbit. This involves an engine startup in about 40 minutes once the kick stage completes its first half orbit of Earth. We'll take a break in the webcast now, but come back live for that engine startup, as well as the final milestone for this mission, payload deployment for NASA's pre-fire satellite. We'll see you back here soon.
Yep. See how the trajectory. So for the people that were here during the Starlink launch, we were talking about orbital insertion trajectory. See how it curves to the right? Well, one is the reason why it's curving is because we're looking at a superimposed view of a geometrically spherical, oblate spherical shape being imposed on a 2D plane. So it's always going to curve a little bit. But it did fly a little bit of a dogleg trajectory. You know how I know? It's straight for a second, and then it kind of curves just a little bit, and then it starts following the curvature of the Earth. In reality, the vehicle took off in a straight line. Weird. So what are these egg-shaped things? Ground tracking stations. It looks like Rocket Lab has one over in Perth. Perth, over there, if I'm looking at that right. Seems to be, they have a ground tracking station in Western Australia. Circles, how do they work? Just like magnets. Just like magnets. And it looks like they have another ground tracking station in Greece and then another one in Spain. Yeah, the map projection is making these look egg-shaped. Once again, we're seeing a spherical view being superimposed on a 2D plane. So, if there was a ground tracking station that was closer to the equator, like that one right there, that could be Indian Ocean. I'm not sure. iOS, but no, not Apple. See how that one's more circular? That indicates that it's closer to the equator because that's what's going to show up correctly on this. See, this is the range, what the ground tracking station can basically see. The reason why the cast shut and why we stopped getting live views is because there's no antennas down here to be able to get a signal from the satellite. This is too complicated. Just say the dish is egg-shaped. It's the dish. We know because it's the dish. They made a movie about it. About the dish. You know what it's called? It's called The Dish. What time is Starliner tomorrow? 10... Be around here at 10 p.m. Eastern... Or 10 a.m. A.M. Be here at 10 a.m. tomorrow. So, in 40 minutes, where can we expect the rocket to be? All right, B-Dag, so... They had an insertion. They're in an elliptical orbit here. So it's an elliptical insertion, meaning that the period is subject to change. But okay, let me think here for a second. 28,455 second stage velocity and Curie separation. So 28,455 kilometers an hour. At 226 kilometers altitude. That was their staging velocity and altitude. So 28,400 indicates an eccentric orbit, just as they said. That's a little bit above what you would need to orbit in a circular orbit at 226 kilometers. 28,000 indicates a higher apogee. So in orbital mechanics, you have apogee and perigee, or apoapsis and periapsis. If these sound weird, it's all Greek to me. No, it's apoapsis. Apsis is Greek. It's a conjugation of Greek. Whatever. Doesn't matter. You have apoapsis and periapsis, or AP and PE. AP and PE is the highest and lowest point in your orbit, or the slowest and the fastest point. AP is always the slowest. PE is always the fastest. If AP and PE are exactly the same, you're in a circular orbit. Now, staging velocity, 28,455, 226. Let's go back and look. Let's take a look real quick. Let's go back to that staging real fast. Let's take a look. See if we still got a signal. It was 28,554, not 455. Did we... Huh. It means upper arch. Oh, there you go. Yeah. Yeah, Rocket Guy, it's slightly eccentric. So in 40 minutes, it's going to be over Europe. About halfway around there. About halfway. So basically what I was getting at is that 28,554, 223, slightly eccentric. You're obviously still in low Earth orbit. The insertion altitude, so the apogee, the highest point of this orbit is egg-shaped. It's slightly crooked from those numbers. You're really looking at around 27,500 kilometers an hour for a circular. So if AP and PE are equal at 225 kilometers, give or take, right, you'd be looking for 27.5. This is 28.5. So the orbit is slightly egg-shaped. Will that influence your orbital period too much? No. So we're looking at about a 90-minute orbital period, if I had to guess. Not guess, it's physics. It's not a guess. Yeah, so 40 minutes would be half your orbital period, so it'll be halfway around the world. So what's orbital period? What does that mean? Is the Earth upset? No, it's not. It's cool. Orbital period is how long it takes at whatever orbit you are to go once around. That's all. So in this particular scenario, right, you'd go up here. That's halfway. If you're superimposing an orbital plane onto a 2D, or an orbital trajectory onto a 2D plane, it's going to look sinusoidal. It's going to look like squiggles, like a frequency almost. The higher the amplitude on that frequency, right, means more inclination, right? No, Kalani, it's cool. It's not cool, is it? Earth's pissed. A volcano's gonna go now, isn't it? Yuck. Anyway, I'm just gonna keep digging that hole over here and making myself look stupider, which is, you know, it's kind of par for the course here. But anyway, so this thing, obviously, big inclination, because look at the amplitude here. It goes all the way down there and goes all the way up. Earth is still down to clown, is what you're saying. Yeah. There's always a volcano going. Earth is always pissed. I'm just gonna let this one go. Yeah, those are your words now. You guys, I made that the joke, and chat kind of ran away with it. Anyway, moving on. Pretty much a polar orbit. It's past the polar orbit, Mab. It's 97 degrees inclined. We're retrograde. If it was a polar orbit, the lines would be very, very steep. But see, look at the trajectory going out of New Zealand. It's that way. See? If we were posigrade, it would be going that way. Sure, every woman that was watching the stream, A, hates me, and B, has left the stream at this point. So, hey, bros, what's up? Cool. Anyway, if you are still here, well, thank you. My jokes are stupid. I'm just a dumb guy from time to time. If you're gonna have to excuse me. All right, like, sorry about that. My bad. My bad. It's the Golden Eyes orbit. Actually, yeah. From what I was looking at from that trajectory, the trajectory is weird on that Golden Eye thing. It's a little strange, but anyway. Why are there no red circles in the Americas? So Rocket Lab doesn't have a ground tracking station that's active for this mission over there. Smart. They're really only going to want ground tracking stations at critical points in the mission. So basically where they deploy the satellite. So the ground tracking station that they have here, it's probably one that's on the Pyrenees, if I'm looking at this right. Actually, the Pyrenees are up here. So it's up on a mountain. That's what I'm trying to tell you. And then this one is Canaries. The reason why is because that's halfway around. They said they're going to go halfway around here and they're going to pop the satellite right there. Could be the Madrid Deep Space Network. Madrid's kind of over here. The center of this seems to be right there. So it's kind of like halfway between Madrid and Barcelona here. I'm guessing it's just, okay, like, here's the thing. We are talking about a radio signal. Okay? It's advantageous to put the dish up on a hill because you get better line of sight coming over the horizon. Anybody watch Three Body Problem on Netflix? The dish on top of the hill? That's on purpose. No, but I read the book. Good enough. Yeah, sometimes you want to put it up. You put it up on a hill. It's easier to see things. Like if we stood up on a hill, it'd be easier to see what's down below you. They didn't say anything about this Deep Spain network. Maybe you don't know about it. Did you see the wording on the new Starship license? The way it's written shows that they could technically use it for more missions, as it states, using a Ship 29 Booster 11 Starship Super Heavy vehicle configuration for the mission profile represented for Flight 4, instead of specifically stating it's for a single flight like Flight 3 had for the Flight 3 mission only. Well, we talked about blanket launch license, Thomas. We talked about that on the Flame Trench actually last week. It wouldn't be the first time. It's possible. No one expects the Spanish ground tracking station. Starship is scheduled for 8 a.m. Eastern Time on June 6th, Matt. Anyway, guys, I'll be 100% real with you. We can wait another couple minutes for the coast, but I'm probably going to log. The reason why, we got another rocket launch in the morning. Straight up. Check this out. Starliner crew flight test 1. The rack integrated controllers on the at Slick 41, the controller mechanisms for the ground launch sequencer have been repaired. Weather conditions are 90% favorable. Liftoff is targeting 10:52 a.m. tomorrow. Launch coverage begins at 6:45, which means I have to be up in about 5 hours, right from like right now. Yeah. CFD countdown and launch campaign is already active. Yep. So here's what I'm going to do. I'm going to go to sleep. Middle Ditch, Rocket Sage, thank you very much. I do appreciate the raids, and I do appreciate everybody's support. I say stupid stuff on here from time to time, but hopefully you learned something. Earth is pissed, maybe. Anyway, so let's see who we can raid. Raid. We're paying it forward to Adtal. Let's go. All right, guys, I'm gonna go. I'm honestly just gonna go grab food, go to sleep, and I will see you here in about 5 hours. Yeah, five. Rick, this is gonna suck. Oh man. Let's go see what Adtal's up to. If you're on the YouTube side of things, thanks for holding it down over there. We'll be back. I'll be back. Oh man. D-Swigert, cool to see you live on YouTube. All right, cool. You saw it. Now I'm leaving. Thanks for watching, everybody. I do appreciate it. Yeah. Hopefully you learned something. That's good, right? GoldenEye. We figured out what orbit GoldenEye's in. Three clicks. Arms the 4-second fuse. Another 3. Disarms it. How long did you say that fuse was?